Today, Andrew and I will explain the Charles' Law. The Charles' Law states that the volume occupied by any sample of a gas at a constant pressure is directly proportional to the absolute temperature. Simply put, at a fixed pressure, if the temperature increases, then the volume increases. And if the temperature decreases, then the volume decreases. For instance, doubling the absolute temperature of the gas doubles its volume. And this is the equation that demonstrates the Charles' law. Vf equals to Vi times Tf over Ti. And this can be written as this form as well. Vi over Ti equals to Vf over Tf. And in those two equations, Vi demonstrates initial volume, Ti represents initial temperature, and Vf represents final volume, and Tf represents the final temperature. And this can be graphed as this. Since V over T is constant, when it's graphed, it's gonna form a linear line. I will show you how the temperature affects the size of the volume. Okay, I prepare like a hot water here, and I'm gonna place the balloon and see how the volume increases due to the temperature. As you guys can see, the volume of the balloon increased as the temperature increased due to the boiling water, and then it popped. Now, Andrew will explain how the cold temperature affects the volume of the balloon.
So as Ellen demonstrated, hot temperature increases the speed of the molecules in the balloon, causing it to swell up and pop. But then oppositely, cold water slows down the molecules and causes the balloon to shrink and shrivel up, but not pop. So this is a picture of when the balloon was put in the freezer and it didn't actually stay in there for a long time. This, as you can see, it shrunk a bit compared to the Toblerone chocolate bars next to it. And here, after 2 days, you can see that it shrunk to less than half its size.